sorry about that. Yeah, so this is more or less the overview of what we are going to talk about today. So I'm going to tell you a little bit about the basics of 3D printing. Then we are going to look at a few printers that we have here at the lab. Then we are going to discuss a little bit of about modeling, slicers, which are used to convert 3D models into instructions for the machines, and then the printing process itself. So about the basics. So 3D printing is an additive manufacturing technique. Additive means that the material is added, not removed, as it is in the case of CNC machining, for example. So also when milling PCB boards, so it's more like a subtractive manufacturing technique where the copper is removed from the plate. And when you're milling wood, then also you start with a solid piece of wood, and then you use tools with flutes in order to remove material from this board to make it smaller in all ways. The 3D printing is mostly about additive technologies, so it adds up material. So there are the three most popular ways how this material is added is selective laser sintering, stereolithography, and fused deposition modeling. So the fused deposition modeling is the oldest technique. So it's when you are depositing more or less fluid material on a flat surface in layers in order to produce a 3D object, layer by layer. And yeah, basically the print going on here is what fused deposition modeling is. So this Lulzbot has a printer that you can see on the screen now is actually melting and depositing plastic layer by layer in order to make this pyramid that you see on the bottom of the screen. And there are many types of FDM printers. So there's even open source projects, one of the oldest ones, RepRap. So this RepRap website is documentation and with instructions how you can build your own 3D printer. I think the idea is to be able to build a 3D printer that can actually print itself. And then most desktop FDM printers that you can buy for a reasonable price are following this design in one way or another. And then an interesting thing about FDM and why 3D printing became popular suddenly was that the FDM technology patent expired, I think it was year 2000. So yeah, it expired in 2009, and which meant that anybody could take this technology or the description of this technology and use it in one's own designs and create one's own 3D printer. And there was MakerBot around 2010 who released their first printer, and they developed it to a really nicely working machine. And then I think the initial holder of the patent, which was Stratasys, they bought the company, and now MakerBot is under Stratasys, if I remember correctly. yeah, as we can see, it is Stratasys that owns MakerBot at the moment. About the other technologies, so in terms of age, stereolithography is a more recent technique than FDM. So it's I don't know, like the naming, it might relate to the way of printing more in a scientific way, but it's basically resin printing. So instead of printing on a build platform from bottom up, it rather prints top down. So usually there's a resin which is photo sensitive. So if the light is being applied to the resin, then it solidifies and creates a solid layer that that is used in order to form the 3D object. Usually it seems as if the object would be pulled out from a resin tank, and the best examples of these kind of printers are the Formlabs. So it used to be Form 1, now there's Form 2, and then just recently Prusa released SL1, similar machine that looks, color-wise, it looks almost the same. Maybe there's a short video about how it works here, but this, okay, so this video shows the difference. And with SLA printers, you can usually achieve higher resolutions and more precise prints, but it comes with the expense of the resin. So the resin is usually more expensive and also more toxic than the filament that you would use for FDM printing. And let's look at the Formlabs. So this is the Formlabs Form 2. As I said, it looks almost the same. And the third and even more recent technology is the selective laser sintering technology, which is usually uses powderized material, and it works in a way that you would apply a layer of powderized material on a build plate, and then a laser would melt these particles of the material into a solid layer to make the 3D object. So as you see, like all of these technologies are about building a layer on top of a layer in order to produce the 3D object. And the selective laser sintering machines are usually okay. 2014, is it really? Yeah, so it's 2014. Yeah, which might be the reason of a scenario that there might be soon affordable SLS printers as well. So if it started with FDM printers and now there are 2 or even more SLA printers around, then we could see in the following 5 years that there are also selective laser sintering lasers printers appearing on the market, which are actually affordable. Let's see, I think I saw also some open source initiatives and Kickstarter campaigns. So, not bad. This is a really small one. Sinterit Lisa. Oh, and it's developed in Poland. Okay, so it makes sense to look into the SLS 3D printers and maybe actually consider them as an option if you want to make really precise parts from nylon or even metals. I think the hardest material that I have seen available from the SLS service providers is titanium. So there are also online services where you can do 3D printing. So for example, Shapeways. Materials. You can even print with steel. As you see, platinum, gold, silver, brass, bronze, aluminium, sandstone. Nice. And then there's another service which is called iMaterialize. And so let's see. Okay, and here you can see what are the options. So also aluminium, high detail stainless steel, steel, titanium, bronze. Yeah, and actually, as far as I know, if you need to print something small and very specific and you know that your design works, then printing with these services is pretty cheap. And the shipping is fast. All you have to do, you have to upload the 3D model. Yeah, so but today we are going to keep talking about FDM, fused deposition modeling printers, because this is the most of the printers at the lab is using this technique. So at the lab we have Lalsbot printers, one Ultimaker, a MakerBot, and then Formlabs Form 2, which is actually an stereolithography printer. But yeah, so the one that you see on the camera, that is actually Lalsbot, TAS number 6. There are also Lalsbot minis in the other room, which have half or 1/3 of the build platform that TAS 6 has. So let's take a look at the website. So these are the 3D printers that you can get from them. It's the Mini, I think we still have Mini 1 and TAS 6. So these are the Mini and that has 6. These are the most popular ones. Yeah, Ultimaker. We don't have the 2 plus, but we have the number 2. It's a very precise and well-designed printer. They're also offering their own filament. And then we also have a Formlabs Form 2. So I showed that on the slides, the website already. So this is this one. Yeah, but so you cannot really do anything with the 3D printer if you don't have anything to print. So first you need to have a 3D model, and there are many ways how to make a 3D model. So you can start with 3D scanning, for example. It's not necessarily the easiest way how to acquire 3D model for printing, but you can use one of the CAD software, one of the CAD programs that are out there, Fusion 360 or FreeCAD or Blender. Then there are also online platforms which are there for sharing 3D models. And at the end of it, so in order to use the models for 3D printing, you need to export them in STL format. So Fusion 360 is this one. We covered it in one of our Fab Academy Fridays back then, like approximately a month ago. So Fusion 360 is very nice because you can model in a parametric way, and you can then right away get into CAM mode in order to produce toolpaths for CNC machines, for example, or you can export a 3D model. You can do all kinds of analytical things with it. Then FreeCAD. So it seems that they are doing a lot of nice updates lately. I haven't checked them out myself, but that's a reasonable option if you are into open source software. And basically it contains all the functionality that Fusion 360 has. Maybe it is not as easy to use, and maybe you do not get the results as fast, although maybe you do if you get good at it. But looks like a nice option, and it integrates very well with the software that is called OpenSCAD, which is more what you see is what you get, or what you write is what you see is what you get interface, where on one side of the interface you write code. So this is a tool where you actually write code in order to get your design. So you can make variables in order to make your design parametric. You can make functions. You can separate the design in multiple files. So what I like about this one is that the interface is very simple, and all you need is one A4 page or maybe A3 page of cheat sheet. So like with all the commands that you can use, and you can design simple parts, or I have seen also that people make really complicated parts, but you can get really nice results with reusing the integrated programming programming options, and the good things about programming in this software. And another good thing is that you can integrate OpenSCAD projects into FreeCAD. So you can use those to, so let's say you can use the OpenSCAD in order to make smaller parts, and then you can assemble them together in FreeCAD. Yeah, this is also a thing that I haven't tried out myself yet, but it could be interesting to try and tell more about it. Then there's Blender. So if you're more into 3D printing, expressive, artistic things, then you can use Blender in order to model really nice things. It doesn't have so much features in terms of CAD design, in terms of it doesn't have relations. You cannot really add constraints. So if you want to be precise and you want to keep iterating on things like the diameter of drill holes, or how parts of a mechanism fit together, then maybe Blender is not the best choice. But if you're in game characters and interesting objects, then Blender might be the way to go. Then there's Thingiverse, and on Thingiverse you can find all kinds of pre-made things. So sometimes you need a part or something that you just need to test your printer, or maybe you are looking for a present for someone, and then this is or you don't have too much time to create something yourself, then Thingiverse, it might be the way to go, because let's say let's look for a reindeer. Yeah, you see have all kinds of reindeers, and it's not only for 3D printed for 3D printing, but you can find designs that could be used for laser cutting also. So for example, this reindeer here, it has all the design files in order to cut reindeer out of a specific thickness of cardboard or plywood or any other material, and then it usually has these thing files, and this particular one is made by using Adobe Illustrator. So you have an Illustrator source file, an exported PDF, and instructions. Let's try to look for something a bit more complicated. Let's say look for anything parametric, and OpenSCAD. So for example, this one, yeah, a Lego brick that can be parametrized, and let's see what do we get when we download the zip. Yeah, so you see there's an SCAD file. You can open it in OpenSCAD. So what was this? OpenSCAD. This one. Yeah, here you go. And then here it seems that this function is used to control it. This 5 might be the rows, the 3 might be the columns. Let's see what happens if we change it to 2. Yeah, columns. This 4. Okay, it takes too long. Let's get back to where we were. So yeah, at the end of it, you need to end up with an STL format. And what I wanted to do also as a part of today, I wanted to show quickly how to do things, how to model something simple in Blender. So you can download Blender from the Blender website, which is blender.org, I think. Here. Yeah. So I think I don't have the latest version, but I still have. Yeah, actually I have the latest version. And here, yeah, it might be very complicated, so don't be afraid when you first open Blender. So all of these panels, they might look complicated, but it's not necessarily the case. It's actually quite easy to use, especially if you want to use it only for mesh modeling. And the interface is quite flexible, so you can adjust it to your needs, and you can hide and unhide things that you don't use so often. So for example, you might not use the timeline right now, and like other things, but there's some few essential things that you should know about to start modeling. So yeah, when you open it up, then on the top side there's as usual like these menu bars, like files, so you can open files and you can save files and export and import things. Then so the render part, when you're just modeling for 3D printing, you're also not going to use help. Every software has some sort of form part. I'll enable just mouse positioning, the mouse thing. And yeah, now, so you can see where my mouse is and what buttons I'm pressing. So this transform panel on the left side, so it's used to transform different properties of the of whatever is selected. So you usually hit A to select all, or unselect all, unselect anything that is selected on the stage. So if you hit A, yeah, you see it's selecting. And then zoom in and zoom out is with the mouse wheel. That is being done with the mouse wheel. Then if you click and hold the mouse wheel and drag around the screen, then it pans around the selection. You usually select individual objects with the right click of the mouse, not with the left click as it is in other software usually. And you can hide this transform panel by hitting T. So you can hide and unhide it with hitting T. So if you need more space, you can hide it. Then another useful panel is another transform panel, which is more for transforming the individual object properties, like the very basic object properties. And the transform panel on the left, it's more to do some specific actions with the object, to do some transformations with it. And one of the first things that I usually do is that I delete the objects that I am not using in the scene. So I'm going to delete this camera and this light. And I'm not going to use this cube at the point as well, because we are going to create things from scratch. And then here in the right side, right panel, we can see this is kind of an outliner, so it's more like a browser of the objects and of the things that we have in our project file. So you can look at it at many different ways. So the default is usually all scenes. It just shows everything that you have on in the current or in all of the scenes that you have in your project file. So if, for example, I add plane that is going to show the plane as an object, and then the underlying mesh in it. But I'm going to delete it for now. And then on the right side, under the outliner, you can see that there's also more like a multi-purpose panel or interface. And what we need to do, we need to change the units. Yeah, the units of our scene to something that we can translate to the real world. And so let's set the units to millimeters here, and the angle is going to be degrees, and this is, now we are going to be able to measure things in millimeters. So usually it's just just a Blender default units, which is nothing specific, without a name. But what we need metric. And let's create an object. So I just created a pyramid, and I printed it just to test how it's going to work with the lecture today, with the presentation today. But how about we create an icosphere, like this. Here in the view, I am going to disable the perspective, so it is easier to navigate. And it seems that Blender created this initially as something very big. So let's scale it down to 2 centimeters. And now, yeah, 2 centimeters is fine. And let's also decrease the subdivisions to 1. So it looks like this. So now we have it as 3 by 3 centimeters here, and we can shrink it down even more. So how about we make it 1.5 centimeters, like this. Yeah, so this panel on the left you can usually use to control the initial parameters of the kind of the object that you are creating. So usually you create objects by using this add menu, then you go to mesh and you create one of these. And yeah, these are like tools in order to create this specific kind of object, and it has usually specific parameters and maybe a few extra things that you can do with it. Okay, I'm gonna hide this for now, and also the other panel. So what we would like to do now is to make sure that it prints nicely on the build platform. So in FDM printing, it is usually that, so if you print from bottom up, then it's nice to have something really flat on the bottom layer. So otherwise it's going to have problems with each next layer. So it can create things like supports, but it's not that, so it's quite risky and not always very good, very reliable. So the safest way is to think in terms of trying to have the bottom layer of it as flat as possible, and do not model in a way that we have too many overhangs, so things that hang over each other. And in Blender, so there are usually two different ways of looking at an object. So one is in the object mode, so you can select the mode here, so object mode. And then if you want to access the individual vertices of the object, you need to switch to the editing mode here. You can do it either by doing this in the menu, or as previously I did it accidentally, you can go to this outliner here and click on the mesh inside the icosphere object. And yeah, it's going to select all the vertices and all the elements of the 3D project at the same time. In order to unselect that, you need to hit A. And then here, while in edit mode, on the bottom here, you will see these selectors, which is going to let you to select specific features of the object. And now it is set to vertices. So with a right click, you can select individual vertices, or if you hold down Shift, then you can select also multiple. And you can move around them by using the arrow keys like this. Then if you select the Edge Select button, then you can select edges like these. And you can also select multiple of them if you hold down Shift like this. And then you can also use the face selection mode, which will let you select individual faces. Yeah, and in our case here in this editing mode, what do we want to do? We want to remove the bottom faces, so we have a flat base of the object. And in order to do that, I was using Shift and right click to select all of them, all of these that you see selected on the screen, and then I will hit X in order to delete those. And I'm going to select delete faces. And now I have an object with a hole on the bottom side. And what I would like to do, I would like to fill this hole. And in order to do that, I'm going to use the vertex select mode, and I'm going to select 3 vertices at the same time, at a time. 3 because it is nice to have everything triangulized. So we can also automatically run a triangulating. Yeah, let's better do like that. So in order to, I'm going to switch to edge mode, and then I'm going to select a loop. By holding, so here what you just saw is that you can select one edge, then hit and hold Alt or Option and hit it again, and it's going to select a loop of edges that is connected to this edge, to the vertices, to the start and end vertices of the edge. So you could also select them individually, but imagine if you would have to select 100 of them, then it would really make sense to hit and hold Alt and select all of them. And then once this is done, you can either go to this menu item, so Mesh Faces Fill, or you can just hit F and it's going to fill this. And now the next thing is that we want to triangulate it. So this is very good for the STL format and slicing in general. And in order to do that, you go to Mesh, Faces, Triangulate Faces, or Control T. So if I go a step back, then I can hit Control T and it's going to triangulate for me. One important thing to check is normals. So in 3D modeling, normals and 3D rendering, normals are necessary in order to understand which side of the face, of the individual face, is the outside, and And it's important also to calculate the correct reflections of the virtual light that you have on your scene. And so in 3D printing, it's important to know which is the outside of the face mostly. And in order to check that, I'm going to open this right transform panel, and I am going to enable the display of normals here, this one, and I can also I need to increase the size in order to see them. And normally the normals, they should be perpendicular to the face, and as we see, all of the faces, for all of the faces, the normals are pointing outwards, and so we are safe. And another thing to do, that we should do, is to check whether the points on the bottom, whether they are on the same line. So if we view it from the front and make it transparent by hitting Z, then we can see that the points on the bottom side are not exactly flat. In order to fix that, we can use a feature that's called snap during transform, and you can access that by using this icon. So you click on that, and then here we can specify what is the object that we want to snap to, so the vertex, and we can move individual vertices around. So let's say that this vertex on the right side is going to be the one that we are going to use as our reference. So we can select individual vertices, and then we can use this Z-axis to move it around, and we can point at an existing vertex in order to snap the selected one to it, like this. So first what I did, I selected the vertex. I'll reset it to front. So with the right click, then with the left click, I click and drag the Z-axis, and I move the mouse cursor, I hover the mouse cursor above one of the vertices, about the vertex that I wanted to snap to on the Z-axis, and then I release. Same I do with all the other vertices that I want to snap. So this one, oh no. Here. Yeah, now it looks that all of them are on the same line. That's nice. So we can zoom out now, and if I had hit tab, or I use this menu in order to switch back to object mode, we are going back to the object mode, and you might wonder why it's transparent. This is because we enabled the transparency, so the mesh display. So I think you can you can change it here, so you can change it from solid to wireframe, and if you hit Z, then you can just toggle between those two. And at this point, we can just check once more if it's the size that we could use for printing. We could actually shrink it to a smaller size, but 2.6 centimeters is fine. And now at this point we can export it. So you go to File, Export, and STL. We choose the location, and we're going to choose desktop. So 3D print demo, and 3D objects. STL, export STL. Yeah. And once we have the STL model on Mac, I think you can just view it in the preview just like that, and you can rotate it around and see how it actually looks. So when you have this STL file, then the next step is to use a special software which is called the slicer, in order to create machine code for a specific 3D printer. So all of the numerical control machines, they are using some sort of G code or numerical control code. In 3D printing, the most popular format that you will see is has the .G code extension, yeah, there are 3D printers which are developing their own slicers, like the MakerBot. It has its own slicer. So Ultimaker has an open source slicer that can be used for printers that are not only Ultimakers. And in the case of Lulzbot, Lulzbot just forked the Cura open source slicer and made their own version based off it. And then one more that I like to use sometimes is Simplified 3D, which is a commercial slicer. You can get two licenses for a license for two computers for around 100 euros. So we can take a look. I'll disable this for now. So if we go to purchase, yeah, it's 150 euros approximately. I don't know what's the exchange rate right now. So yeah, it's 131. Yeah, then there's Cura. And we are going to use Lulzbot Cura, so you can download it for free. So Cura, yeah, Cura for Ultimaker and Cura for Lulzbot. They're both free and open source. And it looks like this. When you open it up, the first thing that you will need to choose is the printer profile. So when you first set it up, then probably you will need to set it up to use one or more printer profiles, depending on the printers that you have. So in this case, what I have on my table is a Lulzbot TAS6. I'm going to select that. And I'm going to use Ultimaker PLA. Actually, I have two types of PLA on the table. One is Ultimaker, and the other one is 3DK Berlin. But most of the PLA plastics, they have similar properties, so they melt. The melting point is in between 210 and 220 degrees. This is what I'm going to assume. So yeah, and then you can choose the detail level of your print and yeah, some other settings, but these become important after you import the actual model that you want to print. And let's import the not this one, but the 3D print demo, the 3D object that we just created with Blender. And as you see, it appears on the build plate of the Lulzbot in the right size. This is because we set the right units in Blender, millimeters. We can also select it, and we can examine if it has the right size. Here we can scale it up or down if we want, but not right now. Yeah, and let's continue with the settings that we want to use. So let's select the intermediate set of options that we can use. It's going to take some time to load it. And here we go. So there are some things that we have to specify for each print. So we have to decide how hollow our object is going to be. So meaning whether we want to fill it completely with plastic, or there are going to be there's going to be air inside. So usually like 20% of infill material works. So the less material inside, the less also material you need to use in order to print an object. And most of the time you don't need it to be full with material. There might be scenarios where you need it to be full with material if you want to have it stronger or heavier. It really depends, but yeah, 20% of infill is usually just enough. Then supports are needed if you have an object that has things hanging over, so-called overhangs. So here we have something that could be defined as an overhang, but the angle of it's not so big in relation to the z-axis that is pointing upwards. So it would be, if it would be bigger, so a bit more than 45 degrees, then we should start worry about that. Actually, when we select generate support, then it usually checks whether it is whether the angle of a wall of an edge is actually, if the angle in relation to the z-axis is actually bigger than a certain threshold, which is usually 45 degrees, and then if it is true, then it generates a support, but we don't need a support at this time. So build plate adhesion, so you can specify you can tell the printer in order to use some features in order to make the object stick to the build plate a little bit better. In this case, it's going to be skirt, which means that it's going to draw a line around it. And yeah, for starters, this is it. And it also shows, it automatically also calculates the G code or the instructions, and then maybe if I remove the skirt, yeah, so it does the calculation automatically without the need of pressing any button. So I'll just switch it back to skirt. Now it's slicing, and yeah, it seems that it's going to print for 18 minutes, which is okay, and it also does some calculation about how much material we are going to use. And yeah, it's actually, it might be important for you to know the thickness of your material. And then if you go to expert, settings, then we can go to material diameter. Why is it so hard to navigate this? Yeah, but somewhere there you should be able to find the I don't know, I think it's here. Materials, if you go to PLA Ultimaker, So the diameter of the filament. So that is quite important to know. So you can use a caliper in order to measure it. I'm going to switch to the camera view in order to demonstrate you that. So for example, all the way along, and in order to tell the diameter, so let's use the caliper just quickly. Yeah, so this is a caliper, the filament roll. So let's take this and measure. So we see that it's 2.9, but yeah, let's stick to the standards, and it's probably it's considered as being 2.85. We could enter like 2.80, 2.9, but standard. So everybody who's selling a filament, they are the two sizes that usually are there. It's 1.75 or 2.85 millimeters. Yeah, I'm going to close this one for now. Yeah, and then when it's sliced, you can save it to file, but before you do so, you can check the layer view of it. And in the layer view, you can see how the printer is going to print the object. So starting from layer 1 and up, and you can see that because of the fact that we chose 20% infill, it is going to create these. What just happened? Okay, I moved it. It's going to create these hollow containers, so this square comb-like structure. And let's see what is going to happen if we are going to increase the infill to 40. Yeah, you see that it's becoming more detailed. Let's go back to 20. And also in terms of time, it is going to print longer. And also obviously use more filament. So let's stick to 20%. And now when it's done, let's save it to file. I'm going to save it in the same 3D print demo folder on the desktop. And notice that the QRLs bot adds printer profile prefix to the file, to the actual file name of the 3D object that we want to print. So we have this 3D object STL in the same folder. Yeah, let's just save the G-code version of it just next to it. And now what we have to do is we have to copy this file to an SD card. So I will take an SD card from the printer. I'll insert it into my computer. Open the folder where I have the file. Select it, copy it, and I'll delete the other ones. Paste it in. Now eject the SD card and switch back to camera. So here I have the SD card, and I'm going to insert it here. So where the control panel is, on the left side, there's a SD card slot where I can insert the SD card. And as you see, the control panel, it reacts. And before I can start printing, I need to remove the existing object that I just printed. I hope that I'm not going to destroy the printer with this activity. Yeah. I think I need some extra tool in order to do that. Just a second. What's going on?
We are watching Inspiration.
What is that?
This is how you
Smart communication technique. Wow.
Did you know that most of the discussions are spontaneous?
I know. Yeah.
I just learned.
Yeah, looks interesting.
It's very interesting.
I am curious what it's like with how to keep cool. That could be interesting also.
Yeah. And then we've been looking on all these binaural videos for how to make your money, how to make yourself money more, and then how you.
Not that easy. Oh, yeah, here you go. Looks like a nice print also. Yeah, here, you can check it out. Here you can also compare it to smaller versions of it. Here these are smaller. Okay, and then one thing that we should do, one should know about printing with the 3D printers is how to change the filament. Because normally the filament should be kept in a plastic bag, like with a silica bag inside to absorb the moisture, because moisture is potentially destroying the filament, so it gets full with water and can cause unpredictable results while printing. So maybe instead of using green, let's try to use this red filament. And the first thing in order to change the filament is that we need to heat up the nozzle. And the nozzle is the actual part that is doing the printing. It is located here on the XY axis here. And the nozzle is the component which is heating up the plastic, which is causing the plastic to melt and decomposing it, so to say. And then around the nozzle there are all kinds of other components. So these fans in order to cool it down. So there's a heater which is heating it up, and then the cooling elements that are cooling it down. Then you can also see a mechanism which is there to pull in the filament. So there are gears and teeth that are pulling the filament in and also pulling it out. So yeah, the build platform. The build platform is moving along the y-axis. The head itself, it's moving along the x-axis, and then so this part is moving up along z-axis. Here, this is the filament roll. So on yeah, all the most of the electrical components are here in the side of the box. And this is the user panel. And the user panel, so the user interface, is you can control that by using this kind of encoder, so knob encoder, which also has the button functionality. So there are two things that you can do with it. Like one is you can turn it in order to navigate the menu elements if they are there, or when you press it. So it acts as a button, and here you can see multiple menu elements, menu items, and you can navigate those by turning the encoder. And in this case, what do we need? We need to control the temperature of the nozzle. I think that you can do it here. So you go to temperature, now hit nozzle, and let's heat up the nozzle to 220. So all you have to do, you have to set up the temperature here, then press the button, and it's going to set this as the target temperature for the nozzle. And here on the display you can see that on the left side, on the top left corner, you see the target temperature, which is 220, and then there's a nozzle icon, and then under the nozzle icon you can see that there are numbers which are rising. So you can come here and take a look. So here you see up there is like if it's ABS, for example, then you don't know about, and you're printing a part which is so printing something with G-code that is made for ABS, for example, then it doesn't have enough heat in order to melt it, and it can cause problems. So yeah, but if you use one, then you always know. Okay, but it seems that it reached 220 degrees. So now what we have to do, we have to go into the menu, movement, and here you have all kinds of things regarding movement, and we need to select the move axis item. So there's move X, move Y, and move Z, but we need to move the extruder. So let's select the move 1 millimeter option, and let's go, let's say 10 millimeters, no, 30 millimeters down. So it starts extruding. Yeah, you can see that it starts to melt and push out filament.
Seems quite inaccurate at the start.
Yeah, I'm wondering, the 3 millimeters, the 30 millimeters is it's probably the length of the filament that is, so of the material that it is considering.
Okay.
Yeah, and then once, so yeah, it's this far, so we should go back the same, let's say 30 or more. So let's go back 50, and we can also help a little bit. To pull the filament out from the mechanism. We need more. Yeah, so it's out, and at this point we can just pull it out from this filament channel here and load the new filament. So in case there's no filament and loading filament is the first step that you do, you need to remember to heat up the nozzle. So some printers will have a separate function, load filament, and they're going to try to do that in automatically, but yeah, good practice is to make sure. So if there's no such function, then always remember to go and heat it up to 220 or whatever the material requires. So let's just check that it's still 220 by going back to the info screen. Yeah, it's 220. And then we can go again. Oh yeah, it actually has a change filament setting, but yeah, let's just try to do it manually. So we go to move axis, extruder, Okay, now it starts coming out again. So yeah, we remove the filament that we don't need. Another good idea is to clean the nozzle before printing. So you would use a little bit of isopropanol and a piece of paper. Just to clean it a tiny bit. Like that. And now we'll go back to the main menu, and I'm going to choose the print from SD option. So I'm selecting the print from SD option, and on the SD card there's only one file, which is the 3D LTAS6 3D object G-code file, and I'm just gonna hit OK. And now the printer is going to start to execute the instructions in the G-code file, and the first instruction is that it needs to heat up the build plate, the build platform, to cool down the nozzle. Then it's going to do some calibration tasks and eventually start printing. And as you see, it starts by creating skirt. Also the soldering, yeah, I'll maybe try it out first and then let's see. If it goes, then it goes. Maybe I can just separate it in two different sessions. I want to take a look what's going on with the live stream. Is anybody watching it actually? What's going on here? There's one watching, but it's me.
Oh, okay.
It's this.
Alright.
And then sand it.
Nice model.
So XTC 3D brush on coating for 3D printed parts. Oh, this. It was here. And yeah, but basically sanding and some isopropanol maybe.
That's two again.
Yeah, it's probably me.
Okay.
Yeah. Maybe not. Maybe yes. So we order from them. So it's quite cheap and also good quality. Filament. Oh, they are filament. Yeah. So they have PLA, ABS, and Willow Flex, which is kind of PLA but a bit flexible. By your own color if you want. You can have custom. You can order custom things. Okay, yeah.
Interesting that the color can get the price up and down so much.
Let's take a look at this like a close up. This looks like a very nice quality print. Look at that.